So we're going to be doing a quick overview of completing the square and the quadratic formula. Here's the actual completing the square technique I'm going to show you guys and talk about. Before I do all that stuff, we need to do a little bit of preliminary stuff, so I'm just going to show it to you instead of writing it all out again. The first thing we need to make sure we know is, what is a perfect squares? What are perfect squares? Perfect squares are these numbers up here, and they are called perfect squares because they are developed or come from the numbers that are being squared, the integers that are squared. So 1 is a perfect square because it comes from 1 squared. 4 is perfect because it comes from 2 squared. And then 3 squared gives me 9. 4 squared 16. 5 squared, and so on and so forth, forever and ever and ever. So these numbers up here are called perfect squares. Continuing on, what is a perfect square trinomial? So a perfect square trinomial is a trinomial that is the result of squaring a binomial. For our purposes in here it is. If I take a binomial and square it, and I multiply it out, distributive property, combine like terms, I get this over here, which is 3 terms, the trinomial part, and it is a perfect square trinomial because this quantity came from squaring this binomial. And this is the foundation for completing the square. When they say completing the square, they mean completing this perfect square trinomial, to create one of these in a problem. Because if I can get one of these, then I know it comes from one of these, a perfect square. And so that's the idea behind it all. So let's take a look. I wrote it like this because I want you to see how the middle term, which is a 2 over here, actually comes from this right here, which is 4 terms. If I put this into a little box format here, box method, you can see that this right here, 1, 2, 3, 4. So 1, 2, 3, 4, and I can factor it. I get back these 2 factors, a plus b, a plus b. So these are the 2 factors that come from this. And so this is another reason why we call it completing the square, because it's like an area model in the form of a square. Okay. Again, complete the square. So what usually happens is we try and use this first part, because the last one is usually just a constant. And we're going to create these 3 things and then find what I need to finish the square off, get this b squared. And so here's how it's going to work. Completing the square is a technique that takes a 3-term polynomial that is not usually a quadratic format, that is not a perfect square, and add or subtract a number that will make the polynomial into a perfect square, into a perfect square trinomial. So now I'm going to show you this with an example and show you how this kind of lays out. Let me get an example going for you. So we'll start with this example. I'll walk you through it, and I'll write some notes for you also. So here's x squared plus 6x plus 7. So if I ask you to factor this completely, we can see you can't factor this thing completely. So we want to get it in a format that allows me to solve it out, is what they're trying to get you to. And so looking at this, and I want to complete the square, we need to make a square. So think of this as 4 terms instead of 3 terms. And you do that by taking this middle one right here and cutting it in half. Okay? Cut in half. So this can be written as x squared. Dividing that in half gives me a 3x, so it gives me 2 3s. So I'd have a 3x plus another 3x, and then the 7. So it puts it in that little format, and then these 2 things right here become this diagonal right there. So I'll have an x squared, a 3x, another 3x, and then in here is a 7, but it's not going to be complete, as you'll see here in a minute. So usually what they do is just put a little box like that, indicating that it's not complete. So following some of the stuff that we know, like the multiplication tables and the stuff we showed you earlier for this, right here, the GCF for these two terms is an x. From these two terms here, we can see that it's an x. X times x is x squared. X times what is 3x? Well, that has to be a 3. X times what gives me 3x, so this has to be a 3. But 3 times 3 is not 7. That's our problem. Okay? So I need to complete this. Right? So what do I need? So what we do is we're basically going to take the x squared plus the 6x. And what we do to complete this is we add something and then subtract the same thing again. So in a sense, we're doing nothing. And then we have that plus 7 on the end. So we're going to add and subtract something. And what happens is these right here, these three terms. So you're going to put something here that will complete the square. We've determined that that number has to be a 9. To complete this square, we need a 9. So if I add 9 and then subtract the 9, these things right here become a perfect square trinomial. So it gives me the x plus 3 quantity squared, which we said from this term over here. So this right here has to be a 9 to make that work, right? Well, what about these back numbers? Well, these combine together, and it gives you the thing that comes that's being added or subtracted at the end here. So a negative 9 plus a 7 gives me the minus 2. Okay? So that is what you get after you complete the square. That's what they're looking for. So if you think back to when we did Algebra 1 together, for those who had me, this is actually basically the vertex form of a quadratic. You can also think of it as a transformational form of a quadratic. Okay? And I kind of showed you an easier technique for finding this, but this is what they look for. It's called complete the square, completing the square. And you'll see it on standardized testing and such. So what happens is, in general, you'll have an x in a simple form. You'll have an x squared plus some kind of bx plus a c. And so the technique you got to go through is like this. So here's how it's laid out. It'd be x squared plus dx. And then we had to add something and then subtract something. So I want to be able to find that number quickly without having to draw this picture. So what you need to remember is you're just simply going to take plus and then minus the same thing. And then the plus c is on the end. So you're going to put it right in the middle here. And what you're going to do is you're going to take half of this number and square it. Take half of that number and square it. So I'm going to add half of that number squared and then subtract the same exact thing. These three terms right here, the first three terms, become your perfect square trinomial. I'm sorry, your perfect square binomial, which is going to be x and then that number plus b over 2. So that is how it becomes. And then this over here is just your leftovers that you got to work out, your constant. This is your new constant on the end. That's the technique they want you to learn. And the reason I'm showing you this is because in some tests, they want you to be able to tell me what that number is right there. Okay? Even though I've shown you an easier way of doing this. Now, the issue then becomes, with this technique, in my opinion, the difficulty of it goes up higher when there's a number in front of the x squared. So what happens if there's a number in the front of the x squared? If there's a number in front of the x squared, you have to actually factor it out first. Okay? So you can actually look at it from this perspective right here. So the a has to come out. You'll have an x squared. You'll have a plus, and then when I factor out an a, you're dividing. So this is going to be b over a. And then normally we would add something and then subtract something in this other one, right? We just take half this, square it, add it, and then subtract it. But because of that a, it kind of modified things just a bit. So we still got to take half of this, and we want to square it. And that plus 1 becomes part of this. So we're going to plus b over a, and then half of that, and we want to square it. Now I'm going to close the parentheses, and I'm going to do the same thing. I'm going to add the same thing, but out here we still have that plus c. So what did I really add here? Well, if I multiply this to that, it's that quantity times a is what I really added. So I need to subtract that same thing. So it's going to be the b over 2a quantity squared, but times a also. So this is the one that was added. This is the one that is subtracted. So as you go through this thing, this then becomes a times x plus b over 2a quantity squared, and then all this stuff out here, which simplifies into this. So you can see that this can get very, very complicated real quickly. But that's how completing the square kind of works. And again, for those who are at home, I should do this so you can pause it and copy this down. So this is what the first page looked like. I'll let you look at it this way too. So here's the first page of notes. Pause. I'm going to slide up so you can go and take a look at it. You can pause it and write it out later if you want. Here's that example plus the notes I wrote about what's happening. Here's the second part that I showed you. Right there. So what if there's a leading coefficient other than 1? Then this gets really complicated, very, very difficult to deal with. Which is why I have the alternate method that I showed you guys when you guys were in Algebra 1. For some of you. Much easier. So let me show you what I'm talking about. So, in this case, we're going to look at the problem a little bit differently. We're still going through the process. Completing the square is to put something into this format right here, which is your vertex form of a quadratic, if we're doing quadratics. Okay, it's usually where it's dealt with. So how do I go about doing this? Well, in this format, that number, the a, is the leading coefficient. H and k are the vertex, the coordinates of the vertex. So literally, I can go right to this form if I find the vertex of a parabola, this quadratic. Well, how do I find those? If you think back, you just need to do the negative a over 2b thing. I'm sorry, negative b over 2a. That is the x-coordinate of your vertex in a parabola. So let's do an example, and I'll show you. I'll show you both methods that you have to go through so you can kind of compare. It's the same, I mean, you're doing the same process, you're just doing it a little bit differently in each case. So you can see this one's a little bit more complicated. Can't be factored. Okay. So just watch. Don't try and copy at the same time. So if you want to complete the square, the first thing I have to do is I have to pull out the 3 from the first two. I'm going to kick that 12 out. Gives me a 3 times x squared plus 5 over 3x. And then I'm going to add something. This will be a plus 12. And then I'm going to subtract something. This is how I lay it out. So what is the thing here that I need to do? Well, it's half of this squared. Half of that is 5 over 6 quantity squared. Divide this by 2, times the bottom by 2, and that's what you get. So then that quantity times 3 goes out here. So 3 times 5, 6 squared. This stuff right here becomes x plus 5, 6 quantity squared. Plus the 12 minus, then I got to work this out over here. That's 25, that's 36. So I'm going to get 3 times 25 over 36. And then we can work that out and get, this is going to be 25, excuse me. We can reduce the 3 into this over here. It gives me 25 over 12. Combining those two, common denominator, 144 over 12 gives me a grand total here of 119 over 12. So that's doing all those things. There it is. Completing the square. But you'd have to remember all those little subtle things that are going on. Here's the technique I want to show you. In the alternate method, I just need to find the vertex of this. Imagine if this was a parabola, y equals. And so I need to find h using the formula negative b over 2a. This is a, this is b, this is c. Those are those coefficients. So then this would be a negative 5 over 2 times 3, or a negative 5, 6. You'll start seeing these numbers popping up, correct? Where did we see 5, 6? That's that number right there, isn't it? Okay. So then what do I do with this number? If this is the x coordinate of the vertex, I got to plug it back in. So then you would take 3 times 5, 6, and you square it. 5 times 5 over 6 plus a 12. And we got to work this out. I'm sorry, it's negative. Excuse me. Don't make that mistake. So squaring this over here gives me 3 times 25 over 36. Look familiar. Minus 25 over 6 plus 12. We know this right here is going to be 25 over 12. I can just do the common denominator right now. This will be 50 over 12 and 144 over 12. And I can work this out, and I'll get 119 over 12, the other number. So this is K. That was H. Here's your template. So X minus H squared plus K. Plugging in here, A is 3. So my answer for that is going to be 3 times X minus H. H is negative, so X minus a negative 5, 6 squared plus K, 119 over 12. And you can see I get the same answer either way. So either you need to do it by quadratic formula, by completing the square technique, or you can just find the vertex and plug it into the vertex form. I do find that this technique is much quicker and much easier, but you should know both. So what this does, it leads to the quadratic formula. The quadratic formula is the formula that is developed by completing the square for a generic parabola or quadratic equation. Quadratic formula is an equation solver. Completing the square just changes the form. So that's the difference. I can do completing the square to help solve an equation. Okay. But usually what people just use the quadratic formula for the most part. If you can't factor it to solve an equation, most people go to quadratic formula next, because that will solve pretty much everything if it's in the right format. Quadratic formula can only be used in formats of this type. It has to look just like this. Ax squared plus bx plus c. It has to be in general form, or in this case, the equation format. And we usually do this if we can't factor. Let me show you how the quadratic formula lays out. I'm not going to rewrite it. I'll just show it to you. Quadratic formula, here's where it comes from. We're going to complete the square with this. Quadratic formula is an equation, so you see that it's set equal to 0. So completing the square, we have to use that technique. So the first two terms, we factor out the a, divide that by a, cut it in half and square it, gives me that right there. Add c, subtract that, same, the opposite of that, and that's where we're at now. Clean everything up, change it to complete the square format like this, a perfect square, and this is where we're at now. I squared and multiplied, and that's where that came from. 2 squared is 4, that's where the 4 comes from. There's only a single a in the bottom because that was an a squared on the bottom, and that's an a, so one of them reduces out. What happened next is these two quantities were moved to the other side of the equation by adding the opposite. And then we found a common denominator of 4a. So this quantity has a 4a. This did not, so you can see I had to multiply top and bottom by 4a. If you want to see where that came from. Combining those together gives me that fraction right there. The next step is divide both sides by this a. That's where the a squared comes from. I have to undo this square, so that means I'm going to square root both sides. When I square root both sides, you have to put the plus or minus. So when you are solving an equation and you square root both sides of an equation to eliminate a square, the plus or minus has to come into play. So we squared the whole entire fraction. By the properties of square roots, I can simplify the square root at the top, square root at the bottom, because the bottom is perfect. The square root of the bottom is just 2a. So when I move this over, I add in the opposite. I see that I have a common denominator, so I can put it into one fraction. And that right there is the quadratic formula and where it came from. So the quadratic formula really makes completing the square, obsolete. But you don't really use it too often in solving equations. You do use it later on in things. Okay, when you need to change the form and put it into that vertex format, then you really need it. So it is a technique you need to know how to use. Whether you use the complete the square format or the one I showed you, the alternate format, just put it into vertex form, either way, okay? But you should be comfortable with one of those methodologies. So the completing the square is quadratic formula is a method. It's a formula for finding a solution to a quadratic equation of this type. That's what it does. Let's do an example. So I'll do this one with you. So here's an example. We'll do 4x squared plus 20x plus 23 equals 0. So we tried to solve it by graphing first, and we realized, well, we're not going to be able to factor this thing. This didn't work for us. It's not going to happen. There's no way I can take factors of 23 and add them to get with the factors of 4 to get a 20. It's just not going to happen. Okay? So what options do I have? Well, I can solve this equation by using the quadratic formula. To do that, you need to identify what A, what B, and what C is. And while you're doing this for the first time, I do recommend that you write it out like this and actually write in what each of these things represents. If it's a minus, then it's a negative, and so forth and so on. And then when you use the formula, x equals, do not simplify anything out. Plug these numbers in using parentheses so you do not make sign errors or any other errors. X equals a negative b plus or minus the square root b squared minus 4 times a times c, and then all over to a. And say the rule to yourself every single time you do it. Say it to yourself. So b 20, b squared, a, c, a. Now I have plugged in the quadratic formula correctly. Any errors that I've made now are just because I did arithmetic wrong. At this point, you want to simplify things out. You want an exact answer, and then you can do an approximate later, but the exact answer is what you're shooting for. So we need to clean all this up. And you can use the calculator to assist you. 400 minus whatever this is over here. You can multiply it all out in the calculator if you need to. 8's on the bottom. Subtract those two things, I get 32. Now you need to simplify the square root of 32. So a little side action going on over here. 32. And a perfect square that goes into 32, the biggest one is 16. So this is the square root of 16 times the square root of 2, or 4 times the square root of 2. Now, you need to reduce this properly. A lot of people do this incorrectly. I recommend highly that you split it between this thing first. So write it as a negative 20 over 8 plus or minus 4 the square root of 2 over 8. And then reduce each individual fraction. Never go inside a radical to reduce. Only reduce the things on the outside. And so you would get 4 into the top and bottom of this one. Four into the top and bottom of this one. And those are your two answers. This quantity plus that, this quantity minus that. Those are your two solutions. These are the exact solutions. If you use a calculator, you're going to give me an approximate solution. Remember, unless they say otherwise, all decimal answers are rounded to 3 decimal places, unless told otherwise. So there's that example that I have in here. And so that ends this video.